Hey, hello everyone. My name is David Izumo. I'm a principal engineer in technical marketing with LiveAction. And today we really wanted to go over a demonstration, an overview of the product, as well as understanding how we fit in from an SD-WAN perspective. LiveNX, LiveAction, is very well known for visual analytics to simplify the network and understand the deep insights into the network. And what I want to do is first off give you an overview of the lab topology and start off with our engineering console. This topology is actually what really helped us gain some traction in the industry, this end-to-end visibility. So the way that you can think about this topology is kind of like a dynamic Visio diagram. Or when we troubleshoot the network as network engineers, we typically go to the whiteboard and we draw a bunch of circles on the board, right? And that represents the devices. And then you start thinking about how are these devices interconnected, so you start connecting them together. And then the next aspect is how are the conversations actually going across that topology? So what we did here was start overlaying NetFlow over this topology. So those pretty colored lines that you see are indicative of all the conversations. These are the NetFlow conversations. Currently, we're displaying all of it by means of the DSCP values. This topology is also made up of multiple sites. So let me help you understand what you're seeing. First off, it's the data center number 1, San Jose, in the upper left-hand corner. And as you can see, it's also very dynamic. You can move these devices around. And the goal there is to try to help recreate the mental model of the network engineer, the way that you really think about the network. So there's the data center number 1 in San Jose, data center number 2 in RTP, as well as 2 remote branches, a dual router branch in Miami, as well as a single router branch in Chicago. And they're interconnected by 2 service providers. So in this case, there's the MPLS service provider on the left-hand side, as well as the internet service provider on the right. You can click on any one of these flows, and you can track that flow end-to-end across the system, from one endpoint to the other across the service provider. Now, by double-clicking on one of these devices, we'll take you into the real-time NetFlow report. I paused it at the moment, but it'll keep displaying the new traffic conversations as it's coming into the network. And now, when you think about NetFlow or IPFix, you always typically think about your 5-tuple, right? Your IP addresses, your port numbers, as well as your protocol. What we did also, like John was mentioning in the previous session, was being able to get that application visibility as well. And a lot of our customers really wanted to get that information. So unfortunately, that wasn't allowed or wasn't capable to export that data in flow records. But what we did was we started making connections to vManage via the northbound REST APIs, and we pulled in that application information via the REST APIs. And then we cross-correlated that with NetFlow and then inserted it into the database. So for example, here, we are able to actually associate these flows. So for example, there's some Facebook, as well as Google Analytics, Hulu as well, along with various other applications, Salesforce as well as RTP for real-time protocol. Now, the other aspect is SD-WAN Viptela also gives an application family also per application. So it's a way to provide a high-level overall grouping. So in this case, we can see that RTP is part of the audio-video family. And again, all that information we're pulling in from REST APIs, cross-correlating it with NetFlow, and then inserting it into our backend database. Now, the other aspect that's really interesting is being able to get VPN or VRF information as well from NetFlow. So that data is coming directly from the vEdge routers into LiveNX, and we're able to display that here also. So all of this traffic is on VPN 10. Now, the elegance of SD-WAN is being able to create topologies per VPN or VRF. So, for example, there might be a finance VPN, and all of that traffic needs to go from branch to the hub, the data center. So it's hub spoke. The other VPNs might be full mesh, or another one might be partial mesh. But being able to understand each of those topologies is really key. Now, a lot of our customers also like the playback capability, and you can simply think of this like a NetFlow or a network DVR. So you can go back in time. We realize you're not going to be sitting at the console all the time. Click a certain day and just simply click play, and you can watch all of those conversations go in and out of the vEdge or any other network device as if you're sitting there in real time. And then you can really identify what the application traffic is, how is that affecting your network, and so forth. Now, with that overview of the engineering console, I'm going to switch gears, and I'm going to dive right into our operational dashboard. But before I dive into the SD-WAN portion, when you first log in to LiveNX, we're going to give you an operational dashboard to give you information at a high level. For example, with the WAN, we typically think of the WAN in 3 dimensions. You think about the sites, you think about the applications, and then you think about the service providers as the traffic is getting moved from one provider to the next, and how you actually allocate applications per service provider. So here's an overall view of the dashboard. And there's many other dashboards available as well. But let's talk specifically about SD-WAN. To operationalize it, we likewise provide this performance dashboard, which gives you information about those 3 dimensions of interest. Again, the sites, the applications, as well as where those applications are going over the various service providers. But in this case, we're giving you that data not based off of utilization, but according to performance. So jitter, loss, as well as delay. Now, in this particular dashboard, we can see that there's actually some issues based off of delay. It's all red on that right-hand column. So delay site to site, delay on the MPLS service provider, for example, and then delay also affecting the SLA classes that are configured within the application-aware routing policy on vManage and vSmart within SD-WAN. So this is just a way that you can operationalize and understand the performance. But let's dive into some of the interesting new aspects that we provide from a visual analytics perspective. Like we were mentioning, being able to understand VRFs and VPNs and per topology, what that VPN looks like is really important. Can you confirm that it's hub spoke or full mesh? So in our latest view, this is a geotopology map. We reviewed earlier the topology on the engineering console, right? And remember those old sites. So there's San Jose, data center number 1, data center number 2 in RTP, as well as those 2 branches, Chicago as well as Miami. So the same context that we were looking at earlier. But now we're interconnecting those sites with all of the conversations that are going from site to site. So for example, right now, we're overlaying NetFlow site to site, and we're displaying it by application name. So by clicking on the legend down below, the display legend, you can see that this is all the voice over IP traffic. This is the RTP traffic. There's Skype, there's YouTube, there's Netflix. So very quickly at a glance, you're able to understand what's happening, which sites are talking to who, and which applications are there. But also important is understanding the policy, the application routing policy. So LiveNX is making, again, northbound API calls to vManage. And by clicking on this View Policy button in the lower right-hand corner, we're going to read in that policy directly from vManage using the APIs. And there it is. And you can use this as a frame of reference as far as what was configured within vSmart. Now, interestingly enough, there's 2 SLA classes, voice video. The latency is 50 milliseconds. That's the threshold that's set within this policy. And then there's another SLA class called Web SLA, and that has a latency threshold of 100 milliseconds. The way that this policy is working is all the traffic is going to be on the MPLS link, but if there's a problem within the network, there's a brownout scenario where the thresholds are crossed, we're going to move that traffic according to policy over to the business internet path. Now, with that in mind, let's take a look at a couple of use cases. So first off, we're talking about VPN topology verification. And again, you think about VPNs like VRFs, a way to segment the network. And a lot of our customers, especially big customers, are segregating their network by VRF or VPN per business unit or various other means. So the way that you can track that per VPN is take advantage of our filtering capability as well as our display capability. So in this case, what I'll do is I'm going to filter specifically for a VPN. We read in all the VPNs that are in this network, and in this particular lab, there's one. It's VPN 10, and I'll go ahead and press the filter button, and now we looked at the backend database and we're showing you all of the VPN 10 traffic for all the applications. Now, we can then identify per application, is it really full mesh? In this case, it's supposed to be. So I'm looking at voice over IP, and we can see across the topology between San Jose, Chicago, and Miami, that's where all the traffic is primarily right now, and it's full mesh voice over IP at this point in time. Now, the other aspect is being able to use logical operators. You can dive in further. So VPN 10, and you might want to do an AND statement, for example, and look at applications on VPN 10. So what we allow you to do is select applications, for example, and I'm going to choose voice over IP. Press refresh, and again, it's going to look similar, but now we're only going to show you all the voice over IP traffic. So now we're really able to see that voice over IP definitely fully meshed between these three primary sites at the moment. Right? So per topology visualization for a VRF is really key to LiveNX. But now another question that comes up with a lot of our customers, and we have a background in quality of service, is what are the markings of these critical applications? We've had many customers over time where they were troubleshooting a Skype for Business or a voice over IP problem for weeks and weeks and weeks, and they had very difficulty pinpointing where that problem was. What happened was some of these enterprise customers were forwarding a lot of traffic to a Catalyst switch. And what happens when you turn on MLS QoS on a particular switch? Trust completely gets turned off, right? So all of a sudden, all that traffic that was marked EF, it hits that trust boundary point and it gets remarked to best effort. We've seen that many, many times. But being able to visualize the network with our engineering console and this topology view really helps. So for example, for voice over IP, if I want to verify the markings, I can just simply display by DSCP. Now in this case, we can confirm, again, our filters are VPN 10. We're looking at the application voice over IP. And now I change the display by to DSCP. And the only DSCP value that we see for voice over IP traffic is EF. So we can confirm very quickly on this topology map that everything is being marked correctly for that critical application. But perhaps if you see a region or a bunch of sites with other colors, DSCP values, then at least you can zoom in very quickly and say, okay, I have a problem with marking of that critical application. I'm going to look further. So these are some of the workflows that are very important. Now, the other aspect is, what happened to voice over IP? Did that traffic take multiple paths? So what you now can do as well is I'm going to display by service provider. So in this case, we're going to look at our backend database, and we're going to start seeing all of the traffic per service provider. So again, the same context is there. We're looking at VRF or VPN 10. We're looking at the application voice over IP. Now, which service providers was voice over IP put over? Where did it get routed to? We see that there's two. There's MPLS as well as business internet. So we know that according to the policy, voice over IP is primarily supposed to be taking the MPLS service provider path. But now we're seeing that it took two service provider paths. So what happened there? So now I'd like to transition into a way that we can troubleshoot a brownout scenario in an SD-WAN environment to really understand what happened. Why did that traffic take two separate paths? So the way that I'll do that is I'm going to look back at the topology, and perhaps you notice that there's some dashed lines between the sites, so site to site. So for example, between San Jose as well as Chicago, there's this dashed red line. But from San Jose to RTP, it's a dashed green line. Those dashed lines represent, at an aggregate level, the tunnel connections site to site. So like John was mentioning in the earlier session, we are able to understand all the tunnels that are pinned up, maybe on the MPLS path, site to site, as well as the internet path, or if there's a third service provider like LTE, then you might see another tunnel there. But it's red. Why? So let's click on that. We'll click on that red tunnel. And again, the context is the same, San Jose to Chicago. And we also show you the opposite direction, Chicago to San Jose. Now, we read in a lot of data from vManage via API. The BFD performance data, we understand exactly what the jitter loss latency profile is site to site. And we're showing that to you per service provider. So notice that on the business internet path, everything is green, right, for each of the SLA classes. When we looked at the policy, there was voice video as well as web SLA, right? So everything's green. But notice on the MPLS path, we're paying a premium for MPLS. Everything's green except for latency. So if we recall the policy, there was only a policy for a threshold on latency. How much latency is there? Well, the latency is at 200 milliseconds over that for both voice video as well as web SLA. You can click on any one of these boxes and drill down for further information. But the next click, I want to try to troubleshoot this brownout in 3 clicks, basically. So this is the first level. We see the top level, what's happening site to site. By clicking on this little button here in the upper right-hand corner by the site-to-site traffic, we're going to automatically bring up a site-to-site Sankey diagram. So again, the same context is there. San Jose to Chicago, and we're breaking it up by application, the VPNs that are running site-to-site, how those applications are being marked, as well as the service provider path that it's taking, and then we're cross-correlating that with the performance metrics. And all of that performance metrics are coming in again from REST APIs. So we're actually correlating a lot of data here. All those lines, these bands, are showing you the amount of bandwidth that's going site to site. We're using NetFlow under the covers to give you that information. And we're correlating other pieces of data with NetFlow. So for example, like we talked about earlier, all of these application names like YouTube or Voice over IP or various others, we're getting that via the REST APIs to vManage as well. Likewise, that performance metric, we're getting that from REST APIs, and that's the BFD data site to site. But now what you're able to do with visual analytics is click play on the bottom, and I'm just going to pause. Now you can step through how that traffic got moved from one provider to the next. So I can keep stepping through, and we're going to start seeing how traffic gets moved. So there were some MPLS issues, then it got resolved, it's all green. Primarily the traffic is over MPLS. We start seeing that it turns red on the lower corner, and then a lot of that traffic gets moved back over to business internet. Now all of that traffic converged over to business internet. Everything's green there, right? So it allows you to really understand what happened over time as far as these applications, the markings, the VPNs, the various paths that the traffic is taking. And now the third aspect is I want more details. As a network engineer, I need to know who was affected, which conversations, at what time exactly did these applications get moved. By drilling down on these individual service providers, we're going to give you time series reports for the details. So for example, by clicking on these service providers, like MPLS as well as business internet, we're going to take you into the details. So again, the same context. San Jose to Chicago over the MPLS path first. Here, we see all of the application traffic, voice over IP, YouTube, SAP, various other applications, all over MPLS, and then it drops off and it comes back on again. Now, what are the markings? There's the markings, DSCP values, EF primarily for voice, best effort for everything else. The VPN traffic as well, in this case, VPN 10, along with the top conversations that were affected down to the end user. But the interesting aspect is I also want to know why that traffic moved, right? What is the performance site to site? So in this case, we're showing you the tunnel performance, first off for jitter. Everything looks fine. Everything is normal according to what we know from the policy that we read in from the APIs. Everything's fine. As I scroll down, there's the loss, and everything is fine even though we're seeing some loss. Remember that the policy that was set up for application-aware routing didn't include a threshold for loss. It was only for delay. So that's a little hint as far as what the problem is. As I scroll down further, notice that there's a critical issue because of delay, right? And when did that delay happen? It happened right around this time, then it dropped off, and then back again. So as I scroll up, notice that right when that delay happened, that's when that traffic came back onto the MPLS link. What does the business internet link look like? Well, I'm going to click over to the time series report for business internet. Notice that it's the exact mirror image between the two. So with those details, we now can answer the questions of exactly when did that traffic get moved? which conversations were affected, right? As well as why, based off of the performance metrics from BFD or bidirectional forwarding detection.
Real quick on that.
Yeah.
So you talked about, looking back, and I know I saw the example come across Twitter. You're not always going to be there. You get a help ticket that said last night something went crazy at 11 o'clock. So that data that you're storing to be able to go back, I know you mentioned 3 years that somebody, was able to go back. Is that stored within your appliance? Is it external storage? What's that all? Or, what should normal be for how far you could go back, I guess?
And I guess, unfortunately, the answer to that is it depends.
Depends on devices and...
Right, and the business policy, the business intent of the end user. But all of that data is stored in various databases within our backend, and we allow for control of how long you want to keep it. So many of our customers keep the fine-grained raw data for about a month, but there are some customers that really absolutely need that raw data for as long as they can. They could, as long as they have disk storage, they can store that information, and then as they start building that up, they can offload it to a backup. Okay. And then if they need to, they can bring that back into LiveNX again by remounting that data. But we keep all of that data for as long as the customer actually needs.
Gotcha.
And to another point, as far as the data that we get, we also bring in the alarms also from vManage. And we created an additional alarm to help understand when an SLA class falls in or out of policy to a tunnel. So as a value add, we are tracking that API endpoint, and anytime there's a delta where a particular SLA class gets removed from the tunnel, we're going to flag it, and then if it gets put back, we'll flag it again. So again, some alerting capabilities within LiveNX. So that's really the two primary use cases I wanted to share today about verifying the VPNs, the VRF topologies, how you can take advantage of the visual analytics at the top level on the geotopology map, and then likewise being able to drill down with a three-step process to be able to understand what happened, why did it happen, right? So starting off at the topology view, understanding site to site that there's some issues, there's some red problems, drilling down to the Sankey diagram to see exactly which applications are being moved, play that back to see it animate over time. And then, of course, drilling down further, because as network engineers, we need to understand the details. So with that time series. So hopefully that helped you understand what we're trying to accomplish with SD-WAN. This is just the beginning. We have a lot more that we want to do. Ongoing capacity planning is also available within LiveAction, LiveNX, where we trend 6 months over time and provide a lot of utilization metrics for 95th and 99th percentile data for your utilization, getting ahead of your service provider or your critical WAN links and how it's being utilized. So all of this really helps our customers to operationalize SD-WAN. So thank you very much for your time. If there's any other questions, we'll be happy to take it. Yeah.
Question. So on the, your guys are ingesting a lot of data. You have a lot of information analytics. Do you do any policy recommendation to modify the SD-WAN policies? That seems to be a common issue.
That's a good question. So in the future, we definitely do want to start thinking about that, especially to identify when that traffic fell away from a policy. So for example, we know when an SLA class went out of threshold based off of the jitter loss or latency profile. What we really want to do is be able to take in the policy and know really from the policy if that traffic is supposed to be over MPLS and not, and help verify that and help you build that policy out. That's something that we're thinking about. The first step, what we wanted to do at least, was bring in that policy so you can see it for the end user. But that's really something that we're looking for in the future. Not quite there yet, but we're getting there.
Is there any way to get access to the data that's collected for my own purposes?
Yeah, definitely. So all of the data that we're showing in this operations dashboard, the web UI, is being driven by APIs to our backend database. So if you'd like to get direct access to our NetFlow, for example, you can make queries using our APIs. We have full documentation, Swagger docs on API, and then you can create your own. You can pull LiveAction the way that you'd like via the APIs.
Okay, very good, thanks.
Yeah, cool.
Any integration with PubSub or message brokers like Kafka or RabbitMQ?
Not quite yet. We are looking at that. We do have, well, with that, well, actually, there is one capability. So for ServiceNow integration today, we do have bidirectional, where we're always querying to see. It's not quite pub/sub, but we're looking back at what's happening from ServiceNow, and then we're writing back to an update on a particular alarm. But we are looking at pub/sub as well in the future.
Yeah, I think the other thing is like as different controllers, have pub/sub published APIs, we can leverage that. But currently, most of them are using like bulk REST APIs, which isn't as efficient. But I think as they scale, they'll probably have us, work through Kafka. And the other thing was about the alerts. So we do get alerting from the vManage as well. So you don't have to be at this console all the time to actually observe it. We'll get the alert, and we'll actually create path change alerts as well. And you can send that to ServiceNow or syslog, email, SNMP traps.
So this is an example of that voice video SLA class where it was out of policy and specifically for Chicago to San Jose. And you can get more information, and like John was mentioning, send that data over to ServiceNow for your ticketing systems within the enterprise.
Now, are the alerts just when certain thresholds are exceeded, or does it do any type of correlation between different alerts and trying to provide insight into potential underlying causes or commonalities between different issues that occur at different times, that kind of thing?
At this point in time, it's an alert specific to that event that occurred. We're not going to keep spamming you, though, all the time whenever we see the same event happening over and over again. We allow you to see that event, it's active at the moment, and then you can resolve it or so forth, but it was not going to keep spamming you. At the moment, we don't cross-correlate all the alerts, but we are looking at that in the future. But with our machine learning capability, that's another aspect that we're looking into.
Yeah, so I think as we work more with Cisco and the different technologies, so this is SD-WAN, but we also have similar visibility to SD access. So looking into the fabric, we have a booth here for those streaming live at booth 1159. So if you want to come by and look at the demo. But overall, the real goal is to be able to connect all these different fabrics end to end, and we provide that visual analytics. And I think the key thing here is like being able to visually understand. So, the human being is the one that's actually implementing this intent, right? And it becomes a policy, and then it gets programmed into this fabric. But the best person to really understand that is that human being, and visual analytics is a really good way for like people to verify, is that really what I intended? So you can imagine as you scale to these number of sites, just visually be able to tell that the site actually worked, the voice over IP is actually taking the path you expected is a very big value add. And I think as some of you have mentioned, the policy, like improvements into the policy is the next big thing that we were looking at because, yeah, we can understand that it's a hub and spoke, but if it's voice over IP, if you made it full mesh, it would work much better. So we can provide that kind of recommendation. We have all the analytics there as well. So.